All right, number 22. First order reaction, A goes to products. We're told that the half-life is 150 seconds. What percent of the sample remains after T equals 300 seconds? So why have they given us the half-life? Well, in order to find out what percentage is left after 300 seconds, we need to find out, we need to know K. And the only way that we can get K is from the half-life. So I'll show you, let me see. The first order equation, A goes to product, is that the ln of the concentration is equal to the ln of the initial concentration minus Kt. And so they're asking me basically for a ratio of these two concentrations at 300 seconds. And so I need a value for K that fits in there. And that's where the half-life comes into play. Because I can use this value of the half-life in the equation that for a first order reaction, the half-life is equal to, and again, if you've been doing these questions in order, then you've seen an earlier question where we derived this equation from this one. And the half-life is equal to 0.693 over K, and therefore, and I'm actually off the page, that K will be equal to 0.693 divided by the half-life. So let's continue down here. So before I can plug into this one, I need to find K. So K is equal to 0.693 divided by my half-life. And that is equal to 0.693 over 150 seconds. And so I see the units of the K value are seconds to the minus 1, and the number itself is 0.00462 seconds to the minus 1. Excuse me. And so now I can use this equation. I think I'll put it together as a ratio. So again, the ln of A minus the ln of A initial is the same as the ln of the ratio of the two. And that is equal to a minus Kt. Let's move this up a little bit. And let's see if I can fit this on. So minus Kt, I know that the T is 300 seconds, and the K value is what we just found, 0.00462 seconds to the minus 1. So I can multiply those two together, and then I'll just do the inverse ln of everything. And, well, we'll do it in steps. So I'll see that this ratio, the ln of it, is equal to, I get a number of minus 1.386. So if I take the inverse ln, I get that A over A initial is equal to the inverse ln of minus 1.386. If you forget the negative sign, you're going to get a number of about 4, and that won't make any sense that you have 4 times more than your initial value after 300 seconds. But when you put it in correctly, you will get a number of 0.25. So you see how you've got a fraction, this times this would be equal to that. So the concentration of A at 300 seconds is only 25% of the initial, and that's the correct answer. The correct answer is A.